Sections 4.3 and 4.4, Day 2, Solving Quadratics by Factoring. So today we're going to basically still just be factoring like we were in the Day 1 notes, but we're going to take this just one little fairly simple step further. And so it's very important that you remember that the following all mean the exact same thing. You're going to do the same thing to finish the problem. It's asking you to do the same thing. It's just going to be worded different, and your problem might look slightly differently. So first of all, if you're told to solve the equation, basically that means you're going to have your quadratic ax squared plus bx plus c, and usually it's going to be equal to 0. You might be told to find the zeros of the graph. Again, you're going to factor and solve it. However, this time it might be a y equals equation instead of equal to 0, but your process is going to be the same. It might tell you to find the roots of the equation. When it's telling you to find the roots, that could be either y equals or 0 equals your quadratic. And then finally, finding the intercepts of the graph. So again, that's going to be y equals. And that's basically the zeros, and the intercepts are just asking you where does it cross the x-axis. So the important thing to remember is that we're going to be using the zero product property. And what the zero product property states as that if a times b equals 0, so let's think about this for a minute. What's the only way that you can multiply two things together to equal 0? Well, then one of them has to equal 0, either a equals 0 or b equals 0. And so we're going to take this, after we've factored something, we're going to have two sets of parentheses, or we might even have a number with an x here out front. Okay, and basically all that means is anything that's being multiplied together, you need to set equal to 0. So you would set the first parentheses equal to 0, and you would solve that and get x equals a number. Or you can set the second parentheses, and this is actually and, you need to set them all. And if there was this third factor, of course that would be 3x equals 0, so of course x could also equal 0 if there was a factor that you took out. And so now let's get to our first problem. Find the roots of the equation, x squared minus x minus 42 equals 0. So first of all, we notice that it does equal 0, so we can just go ahead and start factoring this. And I'm going to kind of go through this process of factoring. I'll go through it step by step, but I'm not going to spend a lot of time talking about it as we did that yesterday. So of course the a times c and the b, and when you list all of the factors, we determine that 6 times negative 7. So we're going to rewrite those, factoring the common factor of x out of the first, and then the 6 out of the second set. Don't forget that it's always equal to 0 in this section. We're solving an equation now. And so now we have our two factors of x minus 7 and x plus 6, and still equal to 0. So now we're going to take each of those factors and set them equal to 0. When we solve each of those equations, we're going to get that x equals 7 and x equals a negative 6. And that's our solution. Alright, so now let's tackle a word problem. Mrs. Vincent has a rectangular vegetable garden that measures 10 feet by 15 feet. She wants to double the area of the garden by increasing the length and the width by x feet on both sides. Find the additional feet x that she'll have to add, and give the dimensions of the new garden. So let's draw a picture. It's always easier if you can, and you can visualize what we're doing. So we've got a garden, 10 by 15, and we're going to add to one end and one width. And we don't know how much we're going to add, but we're going to add the same amount, so that is x. And so now it tells us that we're going to double the area. So we should write down or recall our area formula of length times width. And we want to double the old area. So 2 times whatever the old area is. Well, that's easy. My garden is 15 by 10, so 2 times that equals, and I have that x, that new length of x, and that 15 that I had, so it's going to be x plus 15 is my new length. The width is going to be, again, that x that I'm adding, plus the 10. And so now, on the left I get 300, and I just need to FOIL together the right-hand side. And now the reason I have to do that is because it's not equal to 0, so before I can factor it and solve it, I've got to get it equal to 0. So combining my like terms, bringing the 300 over, and now I've got it equal to 0, so I can go ahead and factor this. And I'm going to skip the a times c steps. Hopefully, if you still have questions on that, you'll come and we can go over those. And then when I set each of those factors equal to 0, I get x equals negative 30 and x equals 5. Well, we're talking about amount we're adding to a garden, so obviously we can't have a negative width that we're adding to increase the area. So my answer is going to be x equals 5. Which means I need to add 5 feet. It's asking me to find the additional feet, so I'm answering the first question. I need to add 5 feet. And then it wants me to give the new dimensions of the garden. Well, if I add 5 feet to the length and to the width, my new dimensions are 15 feet by 20 feet. So now to kind of recap what we just did in that problem, the first thing we had to do after we set up the equation was FOIL it together to get the quadratic. And then we're going to get it equal to 0, so that term that's going to be on one side of the equation, we need to bring it over, so we've got it equal to 0. And then we're going to factor it again, and set it equal to 0, and then of course answer the question. So now let's go ahead and do the next problem. So again, it's equal to 0, so we can go ahead and factor this. My a times c is negative 60, and my b is negative 17. So if I list all these factors, I'm just going to list them down until I notice that, hey, 3 and 20 can give me 17. In fact, it's a negative 60, so since one of them has to be negative, it's negative 20 and 3. And again, I'm just going to go through this process rather quickly, recalling still that when I break up that negative 17 to 3 and negative 20, I haven't changed my quadratic at all. Factoring out my common factor. Remembering that what's in the parentheses has to match, which means I need to pull out a negative 5. And then I have my factors. Setting each of my factors equal to 0, and setting each of those equal to 0 and solving them, I get x equals negative 3/4 and x equals 5. And now the next problem, notice that it's not equal to 0, so I need to get it equal to 0. So adding the 14w and the 48 to both sides to get rid of them on the right, I get 3w squared plus 36w plus 108. Now I could factor this as it is, but it's going to be a lot easier if you can factor out that GCF of 3. So when I do that, it's a lot easier to see that this will factor as w plus 6 and w plus 6. Setting all of the factors equal to 0, well, setting 3 equal to 0 obviously has no meaning. It's not true. It's just a factor. So if I set the w plus 6 equal to 0, I get w equals negative 6. And since this factor happens twice, what that means is that instead of crossing the x-axis, it just comes down and touches the x-axis at that point. And now, of course, let's finish with a word problem. Now, Mrs. Vincent would like to create a uniform pathway around her garden. She expanded that in example 2 above. Her budget allows her to buy and use 200 square feet of paver stones. How wide should the new path be? So let's draw a picture of this. So again, I have my garden, and my garden is measuring 15 by 20 now, and I want to put that border around it. So in order to find the area of the border, because that's what I'm given as the 200 square feet, I need to take the area of the garden and the border. So I'm taking the area of the whole thing, but then I need to subtract the area of the garden. Once I subtract the area of the garden, I'll be left with the border. So the area of the border I'm given is 200, and the area of the garden and the border, because I'm adding the 2x, I'm adding an x onto one end and an x onto the other end, so the length is 20 plus x on both ends. And then my width is 15, plus again I'm adding an x on both sides. And don't forget that I have to subtract the area of the garden, which is simply the 20 by 15. Now again, I need to just FOIL this out, so 200, and just going to FOIL this out. And then don't forget that we're also subtracting 300. So combining all the like terms on the right-hand side, the 300s cancel, plus and minus. So I get 4x squared plus 70x, and that's still equal to 200. Getting it equal to 0. and factoring out a common factor of 2. Now I'm going to factor this, so my a times c is negative 200, my b is 35, and I see that I can break this up into 40 and negative 5. So going ahead and factoring this, setting my factors equal to 0, again 2 equals 0 is obviously not meaningful. X plus 20 equals 0 and 2x minus 5. I get x equals negative 20, which, because again I'm adding a width of pathway, can't have a negative amount. Setting the other one equal to 0, I get x equals 5 halves. So the border should be 2.5 feet wide, and it doesn't in this problem ask me the total new dimensions. So please make sure you come to class with any questions. Remember to go back and do the notes check, and we'll see you tomorrow.